if we miss the detail in the grading. Right. But that's the piece of information that's critical and we will specifically look for. Right. Yeah. Telling me the sign means nothing until you tell me your coordinate. Right? That's why I want you to draw the control volume and show me your plus x plus y. Otherwise, I cannot grade you. Yeah. Fair question. Okay. More questions? Okay. Any question? There was a question asked on this problem for the homework due today. So what was the question? Can you do this one with the hints that I gave you? There was a question, what was it?
Yeah, so with the new equation, we had like conservation basically in the y direction.
Yep.
So if you're assuming that the flow is going backwards, with your controlled volume, do you have a downward contribution from your y velocity?
You do. This is now a 2D problem. It's not symmetric anymore. Because the velocity here we said is negligible. But you do have a momentum in this direction.
Okay.
Right. But for solving this problem, it's not needed. It's not important. Yeah, it's small enough. Right. Okay. Other questions on today's homework? Can you do the unsteady mass continuity equation with the pressure tank? So you're all good? Okay, so I would like to then give you some hints, but not too much, on the 3 sets of homework. They're still on Thursday, but with a lot of ground laid down for So you have a water faucet with a nozzle coupled to the pipe. It turns out the weight of the nozzle is given, so you cannot neglect that. And the volume of this nozzle is also given, which means what? What else do you have to account for besides the weight of the nozzle? If the volume of the nozzle is given, this is water, by the way. You have to also account for the weight of the water, the fluid, right? Because you don't know if it's negligible or not. But I would ask you when you're done with the problem, go look at each component of the forces, body force due to nozzle, body force due to the water, and ask yourself, is that important? There's the free jet at the bottom, you know what that means? In your text, when you read the homework example or example in the lecture, the control volume was chosen like this. I'm going to ask you to think. If you choose a control volume, there's a cylindrical shape. Will that change the answer? Okay? So that's an added piece of the homework that's not asked, but I'd like you to think about it. Do you understand my question? All right, I'll give you the answer. It's the same equivalent in terms of pressure forces. But I want you to think about why. So next time we can deal with that. So problem 39 is a 90-degree elbow placed horizontally. So I have this 180-degree plumbing that turned the flow 180 degree. It's not vertical, but it's placed on the table horizontally. And you have water coming in and out. What is the significance of this word horizontal mean to you? No proof? No weight? Yeah, you got gravity. Because it's supported horizontally by the table. Flow come in, turn 180 and go out. Right? You are asked to find the forces in the X, how many reaction force in the Y direction. You can choose a coordinate, you don't have to use this one. Now for the first time, you don't have a feature. It's a contained pipe. So you have pressure here. By the way, the problem statement is a bit ambiguous in that the pressure given, no specification will say about gauge or absolute. You just say 165 at the exit and 210 at the inlet. Can you deal with this? Do I give you any more hints? The question was asked already on the exit station, which direction the pressure will act? Which direction will this 165 kilopascal act? You not sure? It's always what now? Pressure is always
Inward and normal.
inward and normal. Okay? And with that, I think you should be able to do the problem. Questions? Okay, so this pressure without being specified, gauge or absolute, I'll let you think about that. Is it important? Is it matter? Does it matter? Right? So the third problem is also similar, horizontal lasso, but it's a free jet, so it's actually easy. I won't touch on that. Each one is pretty involved, but it's the last set of problems dealing with 1D momentum. Next step is 2D. So there's not a chance to catch up. Any question on what we have covered? A lot of detail here, but I hope I set the stage to make the 2D problem easier. So I'll give you 5 minutes to do the quiz. If you need more to take picture and upload, I'll give you another 5. If you don't have a quiz sheet, it's in the back. Any extra quiz sheet in the back, please? Bring it up front. Any extra quiz? Yeah, let's go to Mike.
Thanks.
So I think by 10:30 it should be done, but if you need time, you can wait some.